Next we'll come to salt hydrolysis. Salt hydrolysis. The next one is here. That is, rather I should say hydrolysis also. I can say. Now the first point what you are going to write is that first you write that hydrolysis is the reverse of neutralization. Hydrolysis is the reverse of neutralization. Now what is neutralization? Neutralization means when an acid reacts with a base, it forms salt and water. That is called neutralization. What I said? When acid reacts with a base, it forms salt and water. That is neutralization. Reverse means when salt reacts with water to form either acidic or basic solution, not neutral solution. When a salt reacts with water, hydrolysis means that is replacement by OH group. Got it? So when salt reacts with water to form either acidic or basic solution, that is known as hydrolysis. That is called as hydrolysis. So what is hydrolysis? It is defined as a what you can say a reaction in which the the salt reacts with water to form either acidic or basic solution is called as hydrolysis. Got it? Remember it? Neutralization. When a salt reacts with water and it forms a neutral solution, that is not hydrolysis. In hydrolysis, either the solution has to be acid or basic, we can say that. It has to be. Got it? So, it's the reverse of neutralization. It is defined as the process in which the salt reacts with water. Again, I repeat, to give either acidic or basic solution. Got it? So, now next is, there are three kinds of hydrolysis based upon that. We are having salt of hydrolysis of the salt of strong acid and weak base. Then hydrolysis of the salt of weak acid and strong base. Then we are having hydrolysis of salt of weak acid and weak base. Not salt of strong acid and strong base. Hydrolysis of salt of strong acid and strong base never undergoes hydrolysis. Got it? If I say hydrolysis of salt acid and strong base, it itself is wrong. Because salt of strong acid and strong base never undergoes hydrolysis. Why? Because the resultant solution is neutral in nature. So hence salt of strong acid and strong base never undergoes hydrolysis. Got it? Again I repeat the three categories: salt of strong acid, weak base; salt of weak acid and strong base; and weak acid and weak base undergoes hydrolysis. We can say that. Like we can give the salt of strong acid and what you can say weak base. Like strong acid means we can take HCl, and weak base means we can take NH4OH. So NH4Cl, we can say that. Alright, we can take that is ammonium sulfate, we can take that. We can take also like that is magnesium nitrate, we can say that. Magnesium hydroxide and nitric acid. Magnesium nitrate, we can say that. So salt of strong acid and weak base. Similarly, we can have salt of weak acid and strong base. Weak acid and strong base. So weak acid and strong base will be what? Weak acid. Like it can be carbonic acid, it can be acetic acid, it can be formic acid. These are the weak acid. And strong base means like NaOH, KOH. They are the strong base. We can say that. So hence we can have sodium acetate, sodium formate, potassium carbonate. They are the salt of weak acid and strong base. It undergoes hydrolysis. This category undergoes hydrolysis. Next we can have the salt of weak acid and weak base. Weak acid and weak base means both acid and base both are weaker. Like ammonium acetate. Isn't it? Ammonium acetate is made up of what? Ammonium hydroxide and acetic acid. Both are weak in nature. Alright, we can have like magnesium formate, magnesium hydroxide and formic acid. Alright, we can have like ammonium carbonate. Got it? So in this way, from the name itself, why I am saying you these examples, listen carefully. From the name itself, we can find out the category. When I say ammonium carbonate, it should go into your mind that ammonium carbonate means ammonium hydroxide and carbonic acid. We'll give ammonium carbonate. So ammonium hydroxide is what? Weak acid. Got it? Weak base. And carbonic acid is what? Weak acid. So it's a category of salt of strong weak acid and weak base. Alright, in this way, from the example itself, when you do the numericals, you will be getting the name of a particular salt will be given. From the name of the salt itself, you will decide that in which category it belongs to. Whether it belongs to salt of strong acid, weak base, weak acid, strong base, weak acid, weak base. Now, why I am telling you about the category? Why I am saying it? I am saying about the category because in different categories we have got different formulas to calculate the degree of hydrolysis, that is small h. What I said? Degree of hydrolysis, that is small h. Now, how do you find the degree of hydrolysis? Small h. I'll tell you the formula now. Similarly, you will be having the formula pH, and also you will be having the formula you have to calculate, that is your KH. KH is what? Hydrolysis constant. Like we have got it na, Ka, acid dissociation constant. Kb, base dissociation constant. Similarly, KH is what? Hydrolysis constant. We can see that. So in this way, we can calculate KH, we can calculate H, small h, not capital H. Capital H is hydrogen. Small h, that is your hydrolysis constant. Alright. When we write KH, we need to write in this way. This is your KH. This is your hydrolysis constant. Then I say H. This is your degree of hydrolysis. Like we are having the degree of ionization alpha, degree of dissociation alpha. Similarly, your degree of hydrolysis is small h. And next we have got the pH. We have got the pH. That you know it. What is pH? Negative logarithm of hydrogen ion concentration, so to say. So in this way, we can calculate KH, we can calculate pH, we can calculate H, and this is different for different categories. Means salt of weak acid, strong base, weak acid, weak base, and salt of strong acid, weak base. In all the three categories, the formula is different. The formula is different. Alright, for all the three categories. Alright, the formula is different, and hence, according to the name of the salt, you have to determine first the category. Listen carefully. According to the name of the salt, first you need to determine in which category this salt is belonging to, and accordingly you will put the formula and find out the answer which is being asked to you. For that reason, name of the salt is very important. Name of the salt is very important because from the name of the salt itself you need to determine in which category it belongs to. We can say that from the name of the salt itself. So degree of hydrolysis, let me come to you first. As I said, degree of hydrolysis of a salt is defined as the fraction for or percentage of the total salt which is hydrolyzed. It means H is equal to number of the moles of the salt hydrolyzed by total number of moles of salts, what you can say taken. What I said, H is equal to number of moles of salt hydrolyzed by total number of moles of salt taken. So this will give you the degree of hydrolysis. And hydrolysis constant, you know, KH, how will you calculate? You have read it already, Kn, Kw, Kb, we have read it already in the same way. Number of moles of the product by number of moles of the reactant. Got it? And pH also we know it, minus log of H plus ion concentration, and pOH is minus log of OH minus ion concentration. Fine. So in this way, we will take one category and we will determine the formula, because one particular category we will take because it will be the same for all the categories. The derivations, I mean to say, is the same. So here we will be taking a salt of weak acid and strong base. Weak acid, strong base will take the category, we can say that. So under weak acid, strong base, we can have what is that? Sodium acetate, CH3COONA. CH3COONA. Alright, it will dissociate to give you water. Hydrolysis means water has to be there. It will dissociate to give you CH3COO minus plus Na plus. Alright, now actually what is going to happen? See here. CH3CONA plus water, it will give you CH3COOH plus NaOH. Alright, it will give you CH3COOH plus NaOH. Again I repeat, CH3COOH plus NaOH. Then why did I write this? Just I want to show you that what is going to happen. CH3CONA will dissociate to this, and water will dissociate to H plus and OH minus. So this is going to react with this, and this is going to react with this. Fine. Got it? Yeah, that is what I am going to say you. Now, but I will be writing it as CH3COOH plus Na plus OH minus. I am going to write it down. Alright, I am going to write it down as CH3COO, that is nothing but H plus Na plus OH minus. Why? Because it's a weak acid. It will dissociate very feebly. But it's a strong base. It will dissociate almost completely. And salt of what I said, weak acid and strong base. Let me write that. What I have taken it here. Weak acid and strong base. So when it is weak acid and strong base, the resultant solution will be what? It will be nothing but basic in nature. The resultant solution will be weak acid and strong base. The resultant solution will be basic in nature. It will be basic, definitely, because the base is stronger. So hence resultant solution has to be basic in nature. For that reason, you can see the OH minus ion concentration will be more here. Alright, the OH minus ion concentration will be more here. For that particular purpose, it will dissociate very, what you can say, feebly. Which one? Acetic acid will dissociate very feebly, but strong base, it will dissociate almost completely. So hence I have not dissociated this, I have dissociated this, so to say. That is, we can say that. So here I can write it in this way. Finally, CH3COO minus plus Na plus, alright, plus water. We can say that because water again, it's a weak electrolyte, it will not dissociate completely, because this is a weak electrolyte, this is a weak electrolyte, it will not dissociate completely. So hence I kept it as water only. Try to understand. Now this will give you what? That is nothing but CH3COOH, alright, plus Na plus OH minus, got it, plus Na plus OH minus, so to say. So here Na plus is common, it is going to get cancelled, and ultimately I am going to get it CH3COO minus plus HOH will give you CH3COOH plus OH minus. Alright, that is CH3COOH plus OH minus, you are going to get it. This one is. This is the equation for hydrolysis. Ultimately we got it. How do you get it? I explained you. Clear? This is the equation. Ultimately we got it for hydrolysis, so to say. So now I will find it out first, that is KH. KH is what? KH is nothing but product of this CH3COOH into OH minus ion concentration by CH3COO minus ion concentration. You might be thinking, why did not write water? Because water concentration is always 1 or unity. Water concentration is always 1 or unity, so to say. We can say that. Clear? So in this way, this is the formula of KH, we got it. I have just taken an example and explained it. Understood? This is the formula of KH we got. KH is equal to this, we say. Now we'll derive it. Alright, we'll derive the formula for this particular category of KH. We can say that. Now, initially, what we'll do is that initial number of moles. Initially, this will be C. This will be 1. This will be 0, and it will be 0. When we start the reaction, when we start the concentration, initial, the original concentration, this will be C. This will be 1, this will be 0, and this will be 0, because when we start the reaction, product will not be there, only the reactant will be there. And the concentration is, water is always constant, that is nothing but 1 always. Let us say at equilibrium, mind it, I have to write it here, at equilibrium, what happens? The H moles gets hydrolyzed, H moles. So here it will be 1 only, because the water concentration remains constant, always 1, you need to remember it. And this will be nothing but C minus, what is that? It will be, if H moles gets dissociated, it will be how much? It is C minus CH, or I can write in this way also, C minus CH, or I can take C common and I can write C into 1 minus H, fine. This is initial number of moles. When you have started the reaction, this is number of moles at equilibrium, fine. Now, next is KH. KH is what? It is nothing but this into this. The concentration, at that time, the concentration of this and this will be C and C. I have to multiply C throughout. I have to multiply C throughout. That I have to do it. Not it? Clear? Then only I will be getting the concentration of this, and concentration of this is this. So, what is that? It is nothing but CH. Just now I said, concentration of this into this by concentration of this. So, CH into CH by C into 1 minus h. The c gets cancelled. So ch square by 1 minus h. 1 minus h is nearly 1. Already we have seen it in ionic, that is Ostwald dilution law, that 1 minus alpha is nearly 1 only. Because h is very small. So kh is equal to ch square, we got it. So this is the formula we got it. kh is equal to ch square. Fine. This is the formula we got. ch square by 1 minus h. If 1 minus h is equal to 1, then kh is equal to ch square. Or h is equal to root over of, let me write it here, that is h is equal to, kh is equal to ch square. So h is equal to root over of kh by c. kh by c, we can say that. Now kh is how much? kh is nothing but kw by ka. Just now we have done it and we have seen it. kh is equal to kw by ka. kh is equal to. Now how did I got it that it's kh is equal to kw by ka? That is the kh formula, what we got it is that this into this, concentrate this into this by this. Now what is kw? kw is h plus into OH minus ion concentration. Alright, and what is ka? Ka is nothing but acid concentration CH3CO minus into H plus by CH3COH, we can say that. You divide it and see, you will be getting kh is equal to kw by ka. Divide it and see, you will be getting this particular one. Alright, again I repeat, kw is concentration of H plus into concentration of OH minus. Write down, kw is equal to concentration of H plus into concentration of OH minus. Now, what is kh? What is ka here? What is A? A means acid. What is acid here? Acetic acid. Acetic acid will dissociate to give you what? C. Acetic acid, I am writing it here. I am writing it small in small letter. Acetic acid will dissociate to give you what? That is nothing but CH3COO minus plus H plus, isn't it? So if I take the concentration Ka, so Ka will be concentration of this into this by this, isn't it? Concentration of CH3CO minus into concentration of H plus by concentration of CH3COH. So what I said, Kh is equal to Kw by Ka. If you do Kw by Ka, then you will be getting this particular value. What is the value I said? Kh value. Just now I wrote it. That Kh is equal to, what is the value I wrote? CH3COOH concentration into OH minus ion concentration divided by CH3CO minus. You do it and see, you will be getting Kh is equal to Kw by Ka. The value which I said, you will be getting it. Alright. So, hence, I can write it here. That in place of Kh, I can write it. What is that I can write it? Kw by Ka into C. Because just now I said you Kh is equal to Kw by Ka. We got it, Kw by Ka. So hence we got it, H is equal to root over of Kw by Ka into C. Fine. We got the value. Now, next, after that, we will calculate pH. We will calculate pH after that. So, pH is equal to minus log of H plus ion concentration. Alright, pH is what? Minus log of H plus ion concentration. Now here we don't get H plus ion. In the equation what we get it? OH minus ion. So how to calculate H plus ion? H plus ion is equal to Kw by concentration of OH minus ion concentration. Is that right? Kw by OH minus ion concentration. Now here OH minus ion concentration, how much I got it? CH. So I can write Kw by CH. In the equation which I have wrote it already, you have seen it there, OH minus ion concentration, we got it as CH. Now what is H? H we got it just now, that is Kw by Ka into C. Alright, just now we got it. That C into, this will be C into root over of Kw by Ka into C, that is H value I have written it here. Alright. Now I will be doing the, what you can say, minus log of this. Minus log of this, I will be doing it. Now when I will simplify this one, what will I get? I will be getting it, when I will simplify it, what will I get? That is Kw, isn't it? Kw by C here, that is nothing but root Kw. So here what is remains? It is nothing but root Kw remains, isn't it? So root Kw remains and Ka goes up. So Ka, and here C, here root C, alright, divided by root C. So root C I can write it as root C into root C. This C I can write root C into root C. The root C into root C by root C. So one root C gets cancelled, so another root C remains. So root means what? Whole thing is a root. So root means to the power half, I can write it down. You know that. That is, you simplify this one and see it, then you will be getting this value. Kw into Ka by C whole root over. Simplify it and see. Now, hence, if I take the log of this, what will I get it? Log A into B by C. That is log A plus log B minus log C. Alright. Log A into B by C. Log A plus log B minus log C. Where half I can write it in this way. Minus half log this. So, minus half log Kw plus log Ka, minus half I have taken common. Minus half I have taken common. Minus log C. We can say that. Now, if I minus half, if I multiply, what will I get? Minus half log Kw minus half log Ka plus log C. Isn't it? So, what is minus half log Kw? It is pKw. Minus half what you can say, minus half I am saying, half pKw. Minus half log Kw. If I multiply it, what will I get? Minus half log Kw. Log K minus log Kw is what? pKw. So what will I get? What will I get? Half pKw. What is value of pKw? 14. 14 by 2 is how much? 7. Alright? 7. So 7 minus half. Alright? It will be nothing but minus half. That is or if I take minus common here, minus if I multiply here, minus log Ka, it will be pKa, alright, minus log C, it is nothing but log C only, so minus of minus it will be plus log C, understood? I have multiplied minus sign also inside. See here, minus half log Kw. So what is minus log Kw? It is pKw. What is value of pKw? 14. 14 by 2 is how much? 7. Now minus half log Ka. What is minus half log Ka? pKa. Half I have taken common. Alright. Minus of minus half log C. It will be plus log half log C. So again half I have taken common. So this is the final formula you got it for pH. So hence what we got it here? We got the value of pH, we got the value of KH, we got the value of H. So what is KH? We got it. KH is equal to nothing but Kw by Ka. Again I repeat. H is equal to what? Root over of Kw by Ka into C. In the denominator you got it C. And pH is equal to 7 plus half pKa plus log C. We can say that. Now in this way, this is a formula we got it for which category of salt? Salt of weak acid and strong base. Which are the substances? Which are the salt comes under it? Which are weak acid and strong base? We can give some examples like sodium acetate, which we didn't done it now. Potassium acetate, potassium formate, potassium carbonate, sodium carbonate. This all we can say that. Similarly, we can have the category of salt of strong acid and weak base. You derive it, you will be getting KH is equal to Kw by Kb. You can write it down. KH is equal to Kw by Kb. H is equal to root over of Kw by Kb into C. Kb. This I am saying salt of which one? That is nothing but not weak acid, strong base. Strong acid, weak base. Next category I am saying. Got it? pH is equal to half half within bracket, that is pKw minus pKa minus log C. Or we can say pH is equal to 7 minus half within bracket pKw plus log C. pKw I am saying pKb plus log C. Here we got pKa, that will be pKb plus log C. 7 pH is equal to 7 minus half within bracket pKb plus log C. Now last category of salt of weak acid and weak base, we can say that in weak acid and weak base KH is equal to Kw by Ka into Kb, Ka into Kb in the denominator, Kw by Ka into Kb, Ka into Kb both in the denominator. H is equal to root over of Kh, and pH is equal to, we can say, half within bracket pKw plus pKa minus pKb. That is half within bracket pKw plus pKa minus pKb. Or we can say pH is equal to 7 plus half within bracket pKa minus pKb. Again I repeat, pH is equal to 7 plus half within bracket pKa minus pKb. This is about your hydrolysis of salt. This is the different formula for the hydrolysis of salt. The three categories I have said you: salt to weak acid, strong base, strong acid, weak base, and weak acid, weak base. Salt to strong acid and strong base never undergo hydrolysis, but because the resultant solution is neutral in nature. Thank you.